Today we're going to be looking at graphing radicals. Specifically, we're going to be looking at graphing square root functions and cube root functions. So we're just going to start by some general information about them. So the parent equation of each of a square root function would be y equals the square root of x. Of a cube root function would be y equals the cube root of x. The graph of these, when we have the square root of x, the graph starts at the origin. We can plot some points. We know that the square root of 1 is 1, so we'll have the point 1, 1. We also know that the square root of 4 is 2, so the next point on here would be 4, 2. The next integer point would be at 9, 3, because the square root of 9 is 3, and so on. So your graph looks like this. On the cube root function, we do have a point at the origin. If you think about the cube root of 1, that's 1 as well, so I'll have the point 1, 1. The next integer we can take the cube root of is 8, so 1, 2, 3, 4, 5, 6, 7, 8, and the cube root of 8 is 2. But if you think about it, the cube root of 8 is also negative 2, and the cube root of, the cube root of negative 8 is negative 2. The cube root of negative 1 is negative 1, so we also have the point negative 1, and 2, 3, 4, 5, 6, 7, 8, negative 8, negative 2. So our cube root function looks like this. It has a turning point at the origin. So those are our functions. If we think about the domain of both of these, domain are all the possible x values. So of my parent function of square root of x, all my x values are greater than or equal to 0, so our domain would be x is greater than or equal to 0. On my cube root function, x can be any number, positive or negative, so we're going to say x is an element of all reals. Okay, so now what we're going to do is we're going to look at a table of what happens when we add and subtract to the square root. We're going to make a big table. We're only going to fill in part of it today. The rest we're going to fill out in class tomorrow. So if you make a big table across your paper. Oops, sorry, that looks very ugly. We're going to have the equation, and then the graph, and then the transformation, and then we're going to have the equation again, and another graph. We're going to do one half of this with the square root function, and the other half with the cube root function. Okay, so we're going to have 4 different things. 1, 2, 3. Okay, so what you're going to do is you're going to build basically a 4x5 grid, and then with your title row. The transformations we're looking at are a vertical transformation, a horizontal translation, sorry. By transformation, I meant to write translation. A horizontal translation. X-axis reflection. And a vertical stretch or shrink. Okay, so for right now we're just going to deal with the square root function, and then tomorrow in class we're going to look at the cube root function. So if we have the equation y equals the square root of x plus 5. Notice the plus 5 is not inside my square root. So what that's going to do to my graph is that's going to move it up 5 units. So it'll go up 2, 3, 4, 5, and it'll go out from there. So it's just taken my square root function and it's moved it up 5 units. Okay, so vertical translation, when it's outside, that's what's going to move it up or down. So this would be up 5. If it was a minus 5, it would have moved it down 5 units. If we have y equals the square root, oops, forgot my equals, equals the square root of x minus 2. Notice now that the minus 2 is underneath that radical, so it's inside. Because it's inside, that's going to move us left or right. And again, just like we've done before, that'll move it the opposite direction. So an x minus 2 is going to move it to the right 2 units. And so it would go over 1, up 1, over 4, up 2 would be your points that are on there. So it moves it to the right 2. So inside goes opposite of your intuition, so a minus 2 would go right 2 units. If we have y equals negative square root of x, okay, so we've seen this before. When there's a negative out front, that reflects the x-axis. So now it's going to go over 1, down 1, over 4, down 2. Oops, did a very bad job. There we go. Okay, so use the one that actually goes to the points. So it just reflects the x-axis. And then finally, vertical stretch or shrink. If we were to have y equals 3 square root of x, that's going to vertically stretch it. So it's going to multiply my y values. So instead of going over 1, up 1, now it's going to go up 3. And instead of going over 4 from my origin, having the point 42, we're going to have the point 46. 3, 4, 5, 6. Okay, so that takes my square root function and it vertically stretches it. It basically just makes it taller. So, just like we've looked at before, outside the square root moves it up or down. Plus moves up, minus moves down. Inside the radical, inside the square root, it moves left and right opposite. So a minus is going to go to the right, a plus is going to go to the left. A negative out front is going to reflect the x-axis. A number out front, if it's bigger than 1, it's going to vertically stretch it. If it's between 0 and 1, so if you have a half or a third, it's going to vertically shrink it, so your graph is going to get shorter. We're going to work on the second half of our table in class tomorrow, so just leave that blank and we'll fill it in tomorrow during class.